In this section, we're talking about geometric sequences as exponential functions. In Algebra 2, you will go on to discover more things about geometric sequences and the recursive formula. Right now, we're not going to be doing that. In this section for Algebra 1, all you need to be able to do is decide if the sequence is arithmetic or geometric or neither. So in arithmetic, you're adding the same thing in between each number, and geometric, you're multiplying the same thing in between each number. If it is geometric or arithmetic, you're going to continue the sequence. All right. And I already said that you will not have to find the nth term for the geometric sequence until Algebra 2. So here's some examples that I have. Determine whether the sequence is arithmetic, geometric, or neither. And I said in arithmetic, we're adding the same thing, and in geometric, we're multiplying the same thing. All right. So in A, we are going from 4 to 1. So that would be subtracting 3. And this we're adding 1. So that's neither. There is no pattern there. Okay. In B, going from 10 to 20, so that could either be multiplying by 2 or adding 10. And then 20 to 30, 30 to 40. So you can see that we're adding 10 each time. So I'm going to say it's arithmetic. And the common difference is what I'm adding between each number. So the common difference is 10. All right, in C, we're going from 4 to 20, and then 20 to 100. So I'd either be adding 15 or multiplying by 5. So I'm going to be multiplying by 5 because 20 times 5 is 100. So I can say it's geometric. And instead of common difference, you have a common ratio of what you multiplied by, which is 5. Okay, this last letter D, we've got 212 to 106. So I'd be subtracting by 106, or a lot of my students say dividing by 2, but you have to remember we're not dividing. We always multiply with geometric. So if I'm dividing by 2, what is that multiplying by? I can say I'm multiplying by 1/2, okay? Because you can't say you're dividing. So multiplying by 1/2. So 106 multiplied by 1/2 is also 53. So it's geometric. And again, the common ratio is 1/2. The only other thing that you have to do in this section is not only to decide if it's arithmetic or geometric, but then if it is, to find the next 3 terms in the sequence. So we have to decide, to be able to do that, we have to decide what we're doing. So in A, we're going from 2 to -10, and then -10 to 50. So I can say if I multiply by -5 here, that would 2 times -5 is -10. -10 times a -5 would be a +50. So obviously it's geometric, and we're multiplying by a -5. So I can go 50 times the -5 would be -250. So that's the first one. Then if I've got -250 times -5, that would be positive 1,250. Then you get 1,250. Sorry, that's kind of weird looking. 1,250 times -5 would be a negative 6,250. So your final answer would be these 3 numbers. Okay, in B, we have 36, 12, and 4. What are you doing? Well, you could say you're dividing by 3, but you can't divide in geometric. So we have to say we're multiplying by 1/3. So if I did that, multiplying by 1/3, I would get that. So that would be my common ratio. So 4 times 1/3, you have to put that over 1, so it'd be 4/3. And then that times 1/3 would be 4 over 9. Then 4/9 times 1/3 would be 4 over 27. So the next three numbers in the sequence would again be 4/3, 4/9, and 4/27. So I'm going to put 4/3, 4/9, and 4/27. And my students, please write it like this in my final answer. Don't just circle individual numbers. All right, the last one we have is 400, 125. So again, what are we doing between all these? Dividing by 4 or multiplying by 1/4? So we take the last number of the sequence and we multiply that by 1/4. We get 25 over 4. Multiply that by 1/4 and get 25 over 16. Multiply that by 1/4 and I get 25 over 64. So my next three numbers in the sequence, and I can write those as my final answer. So 25 over 4, 25 over 16, and 25 over 64. And I'm sure every math teacher in the world would agree with me and say, please show your work for this. Thank you.